Here we go, math paired conversation protocol. Again, this is a protocol from the Jeff Swears website, jeffswears.org. There is a ton of information here that you can use, sample videos of the work in action in the classroom, various protocols for academic conversation, rubrics for judging academic conversations, how to do formative assessment. There is so much in this website. Highly recommend it. So now I'll walk you through just one example that we pulled from here. The math paired conversation protocol works really well with problem solving in math. I could see it working in science as well. Anything that involves a problem or some kind of question where there could be more than one answer. And so what students are going to do in this paired conversation is work through a process of solving and evaluating their methods and determining which is the most effective, etc. So we start out with a problem. Now, of course, I would have done lessons before this about the value of the coins and adding money and all of those kinds of things. So we're jumping in partway through money in math. So Miss Ryder found some change in her pocket. She needs $1.25 to buy a drink. How much more money does she need? Now, we do not jump right into solving problems. First, we create our supports. When we're thinking about our supports, the question to ask yourself is, when I give students this problem and they start working on a solution, whether by themselves or together, what math will they need to know? Right? They'll need to understand decimals. They'll need to understand coin value. What is all that background knowledge they will need? But also now I'm challenging you to think, what language will they need? And when we create our anchor chart around money, I want you to consider what language you are going to help provide them so that their conversations stay academic and so that you are moving them up the proficiency level. So remember that I+1 we talked about in the other segment. You want to be moving them through the proficiency level. So before I start solving the problem, I may have already started my anchor chart. At this point, I probably have an anchor chart that has pictures of the coins, the value of the coin, some comparatives like 1/4 equals 2 dimes and a nickel, or 1/4 equals 5 dimes, or 1/4 equals 25 pennies, with all of that labeled with very clear visuals, just so students have the information they need to start. Now, as I add to my anchor chart, I need to think of the words we're going to use to solve. So I know we're going to be doing some subtraction. We're going to be doing some adding. So I'm going to think about the sum or the difference. I want to talk about those. How much more, in addition to, things like that they're going to need to talk about this topic. We'll then put our anchor chart together. And remember, our anchor charts are looking at word level and sentence level. So what I was just giving you is the word level. We are putting all the words that students might use. And later, when we get to the paired conversation, when we start thinking about clarifying and analyzing and justifying, you want to be able to say, look at the anchor chart. When I come around to you, or when I listen to you online in your breakout groups or with your partner, or when you respond to me with an answer or a suggestion, I want to hear you use these words. These are the words I want to hear from you. Be very explicit and clear that we put this anchor chart together for a reason, and I want these words to be included in your response. Right there, you're providing the +1 to move students up in their proficiency level by adding more specific and technical vocabulary. Now, for the sentence level, think about the kinds of things students are going to be saying. They might say, I think Mrs. Ryder needs blank more because. In addition to the blank sense, she will need blank, something like that. And you want to provide some of those frames and model and practice with those frames so that students begin to understand how to put their ideas together. When you answer math problems or you share your thinking in math, sometimes the wording is different. Sometimes it's hard to get those ideas out of your mind, even when you know how to do the calculation. So providing a few frames and modeling a few examples of how you would start that conversation is very important. And again, when they are on your anchor chart, students know when I am listening to your conversation, when you are talking to a partner, when you are responding to me as your teacher, these are the kinds of sentences I want to hear. And your frames you are targeting also at the I+1, you're making your frames a little bit more complex, a little bit more complicated than what students normally would say when they're speaking informally, because we want to reinforce that math talk is academic, and therefore it sounds a little different, and we have to boost up our proficiency level a bit. So now then we come back to our problem. Like, okay, now you know the words I want to hear, you know the kinds of sentences we should be hearing in your conversation. It's time to start our paired conversation protocol. When you use protocols, it frees the students' minds to focus on the content and the language and less on directions. So again, I would suggest that you find these kinds of protocols and we go through the same process on a regular basis, regardless of whether it's language arts or math or science. Because when students can predict the next step, when they know where you're going, their background knowledge is already flowing. They're already coming up with some ideas. They think they know where you're going. They're plotting their next move. They're thinking of the words to use. And they are so much more focused on the content and the language because they know the directions. They know where you're going. Can't emphasize enough how important that is. So in the math paired conversation protocol, step 1, paraphrase and clarify the problem. Now this is set up as a paired conversation. You can do small groups. You can do pairs, whatever works for you. There's more accountability, I believe, in pairs, but it depends on what routines you set up in your classroom. So at first, students will need some help understanding what this is. So paraphrase and clarify. Remember, we always think messy, objective, kind of style. What does paraphrase mean? And take their input. Paraphrase means you're just going to say it a different way. What is this question asking? Are you sure you know? What does it want to know? Who are we talking about? What should our answer be? Is our answer a name? Is our answer a thing? Is our answer an amount of money? Just talk it through and figure out what exactly does this problem want you to figure out. And just spend some time talking about it. Again, you get the conversation going, the background knowledge going, and students who have a more difficult time with the way math is worded will get a chance to talk that out with their partner before they begin. We try to use consistent icons for things in the classroom. So whenever I want students to think, pair, share, or do something together in partners, I try to use the stick people kind of idea and say, this is two people, right? When are we working by ourselves and when are we working together? Because in this conversation protocol, we go back and forth between independent work and partner work. So in step 2, you are thinking with your partner, You're coming up with an estimate. What does estimate mean? What does it mean if you estimate the answer? You shouldn't have your pencils out. You shouldn't be doing any math right now. Just coming up with an estimate. And you can talk a little bit about what that means. You have the icon for partner work. So think with your partner. In step 3, we are going back to independent work. There's only one person in this image. So you are independently going to try to solve the problem. Remember, this is all partner work. This is our paired protocol. It is okay if you're not sure what way to go or what to do. It is okay if you don't find the solution right now, because this is a process that involves a number of steps. And by the end, you will get it. So do the best you can right now. Come up with some kind of plan of how you might solve this, and just try it on your own. And we always link it back to our thinking verbs so that we are consistent in the academic language and what that academic term means. And we always use the same icons. So we have our solve thinking verb card there as well. After some time working independently, now you are going to come back to your partner and you're going to share your method. Now, what you see in our picture here is that these two people have two different ideas and they're both smiling. So it's okay if you have two different ideas about how to share how to solve this problem. In some ways, I think it's even better that you have two different ways, because we should all have backup plans in case something doesn't work for us or something's not quite our style. So partner A, you're going to go first. Partner A, you're going to tell partner B how you solve the problem. Partner B, you are going to listen. You are going to ask clarifying questions if you need to at the end. Partner B, you do not get to say yes or no or right or wrong or whether you like it or not. Now is just your time to understand what partner A was thinking. When you are finished, you switch roles. Now partner B is sharing and partner A is listening to understand, clarifying questions only. And they take their turns to share. You might need to structure that a little bit more. You might need an extra slide with very explicit directions in the beginning. You may want to time it and just say, right now, partner A is talking, partner B is listening. And after a little bit of time, when they seem to have wrapped up, then you give the next set of directions. The more you do it, the more you can just say, okay, this is A-B share. Remember, we're just clarifying. But in the beginning, you may want to break it down a little bit more. Step 5, we're still working together. You are going to discuss and evaluate which method is most effective. Now, in the beginning, we have to spend some time talking about how you can have many different ways to solve one problem. And you could have 5 different ways that end up with the same solution. So all of them are correct. But there is probably one that is more efficient or quicker or easier or faster or just less complicated. There could be a lot of different ways you decide which one is most effective. That does not mean that the other partner's idea isn't good or doesn't matter or we're throwing it away. It just means this one time, we think this one is more effective and why. And again, we bring back our thinking verbs. We're comparing our two methods and we're going to evaluate them. When you evaluate, you are giving your opinion. You're talking about the effectiveness. You're not talking about the people. You're talking about the ideas. We often say, tough on ideas, soft on people. We're not evaluating you as a person. We're evaluating that method of problem solving. So once you get it down, they jump right in. They don't take it personally anymore. But in the beginning, until you build those relationships. It could be, you have to kind of tiptoe through those. Step 6, discussing similarities and connections. So you may have decided that partner B's method was the most effective, but there were probably a lot of similarities between the two, which made it a little hard to decide which was most effective. So where were your methods similar? Did you both use subtraction? Did you both use addition? Did you both have a certain connection you were making to the coins? What were some of the things you did that were the same, even if you had different processes in the end? Step 7, select a method and determine a final solution. Now, you may decide with your partner in the end that neither partner A nor partner B had the best solution, that once you talked about it, there was another way that would work even better because you compared notes. You figured out which things were similar and worked well, and you can go back and tweak it and come up with an even better way. Or you may just use one of the ways you already tried. But however you decide to do it, together you select how you're going to solve this problem and you come up with the final solution together. Be ready to show and explain your work. Then we would do some of that. I would probably pause there and look at what's going on, maybe stop and share some of the different ways that students solved the same problem, maybe pick 2 or 3 that were different, so that we can continue to reinforce how there are many different ways to solve. And as long as you come out with the solution, they have equal value. Our exit ticket usually at the end is step 8, where now you are going to create a similar problem that we will use as practice tomorrow when we try this again. And this will be a way for them to see if they get what really the problems are asking and how they're put together. And then it will give you a good way to start the warm-up tomorrow with using those problems, picking a few of those to use as your formative assessment to get things started again. And then we can go through the process again and switch topics, lots of possibilities. So there is the math paired conversation protocol. Again, lots of tweaks and adjustments you can make along the way. These steps are in this order to incorporate discourse, language and concept development, critical thinking, problem solving, cooperation, collaboration along the way. So be careful about removing any steps, but I think there are plenty of opportunities to add a few pauses and conversations in between to make sure that we maintain that relationship and atmosphere of trust and risk taking.